evaluate the following, and we have several division problems. So let's do them one at a time and remind ourselves how the division process works. We'll start with 128 divided by 8. Now, with the division algorithm, it's called. Algorithm is a slightly more mathy word for a process. We have a division sign like this, and the number that comes first goes on the inside. So 28 goes on the inside, and the number that comes second goes on the outside. The order matters with division. So it's always the first number that goes on the inside and the second number that goes on the outside. Now, once we have it set up, we can start the process of going through and doing the division. We go from left to right with the digits inside the division symbol, and we're looking for a number that's larger than 8. So 1 isn't going to be good enough. We're going to need to look at these first two digits to get 12. And so we have to ask ourselves, how many times does 8 go into 12? And the answer is 1. 8 goes into 12 one time. Once we've figured that out, we multiply. 1 times 8 gives us 8, which we write down here, and we subtract. 12 minus 8 is 4. And so what we get here, this 4, is actually the remainder when 12 is divided by 8. 12 divided by 8 gives us 1 with a remainder of 4. That's actually what's going on there. And then what we're going to do is we're going to bring down this 8 next to the 4, 48, and we want to see how many times 8 goes into 48. If you remember your multiplication tables, 6 times 8 is 48, so it goes in 6 times. 6 times 8 gives us 48, and when we subtract, we've got a remainder of 0, and so we know that our final answer here is 16, so 128 divided by 8 is 16. Now, I want to show what happens if we do something a little bit incorrectly. All right, so what I'm going to do here is I'm going to make a couple of mistakes and see what happens, just so that we all are on the same page. I'm going to rewrite the problem here. 128 divided by 8. I'm going to do the first step correctly. 8 goes into 12 one time. 1 times 8 is 8. Subtract and get 4. We bring down the 8. Let's pretend that we didn't remember that 6 times 8 was 48, that we don't remember how many times 8 goes into 48. What we can do in this situation is guess and check. So let's pretend that we think 8 goes into 48 5 times. Let's write 5 here. If we continue, 8 times 5 is 40, and when we subtract, here we've got 8, and in this case, 8 is too big. We know that the remainder is what we get when we do the subtraction, and we need a remainder to be less than the number we're dividing by. So that tells us that we were incorrect. That tells us that this 5 is not correct. So then we have to try again. I'm going to rewrite this. Let's, again, pretend we got the 1 right. Now, this time, let's say that our guess is too big. Let's say, oh, I think 8 goes into 48 7 times. Now, when we multiply here, 8 times 7 is 56. And we can't actually do this subtraction because 56 is larger than 48. We would end up with a negative number, and we're not allowed to have negative numbers here. So in this situation, because we couldn't do the subtraction, we can see that our guess of 7 was incorrect. And so really, what assures us that we have done it correctly is that this number down here that we get, this remainder must be less than the number that we're dividing by, which in this case is 8. So that's just a little bit of an aside to show you the things that can happen if you end up putting an incorrect number in your division. Okay, let's move on. Let's look at some other examples. Here we have 144 divided by 9. This is another way to express division. We have the traditional division symbol in the first problem, but a diagonal bar also works. So the first number again is going to go inside, second number goes in the outside, and then we go through the process of division. 9 doesn't go into 1, but it does go into 14 one time. 1 times 9 is 9. We subtract 14 minus 9 is 5, which is good because we wanted this remainder to be less than 9. Bring down the 4. How many times does 9 go into 54? Well, 9 times 6 is 54. So the next digit's going to be 6. We've got no more remainder, so we know we're good. And coincidentally, we get the same answer as the last one, 16. Total coincidence, though. All right, let's look at the next one, 288 divided by 48. The first number goes inside the division symbol. The second number goes on the outside. Now 48 doesn't go into 2. It also doesn't go into 28, but it will go into 288. And we have to figure out how many times it goes in. Now, most of you probably don't know off the top of your head how many times it goes in, but we can use some estimation here. 288 is about 300, and 48 is about 50. And if we think about that, 50 goes into 300 6 times. So we're probably going to be about 6 here. Could be wrong, could be 5, could be 7, we're not sure. But you can use your estimation skills to figure out more or less what the answer should be. Let's check to see if it's correct. 6 times 8 is 48, so I bring down the 8 and carry the 4. 6 times 4 is 24, and when we add 4 to that, we get 28. So we do end up having the right answer, because we get 0 as a remainder, and so 288 divided by 48 is definitely 6. If we had accidentally put 5 here, then we would have had too big a remainder, and if we had put 7, then when we multiplied, we would have gotten a number that was too large there. So there's always checks in these problems to make sure that you're getting each digit correct. All right. Let's look at the last 3 problems, and I'm going to do them down here just because there's a lot of space down here. 0 divided by 5. We could also write that like this, 0 divided by 5. I'm also going to look at 5 divided by 0. And we'll look at 0 divided by 0 in the end. So here, we've got 0 divided by 5, and there's a rule that says if we're dividing 0 by a whole number, like 5 or 4 or 12 or 37, the answer is just going to end up being 0. Because if you split $0 equally between your 5 best friends, each of them would get exactly $0. Taking 0 and dividing it into equal parts always leaves us with 0. Now, this other problem, on the other hand, is different. If we take $5 and we split it, we divide it evenly among 0 people, that doesn't actually make sense because the money has to go to someone. We can divide money between 3 people, we can divide money between 8 people, we can divide money between 700 people, but we can't divide it amongst no one. That doesn't make sense. And so in this case, we say the answer is undefined. And the rule is we cannot divide by 0. It is a rule of mathematics. When I first learned this, I thought there must be a way, and I tried to go home and figure out some sort of special thing that could be done, and I went to my teacher excitedly when I thought I had figured out the answer, and he showed me that I was wrong. Basically, in a calculus class, you will look at dividing by zero, and it's not something you can do, but there are different situations where there's kind of more information involved, and you can use that extra information to figure out kind of what's going on. But for right now, you just need to know we cannot divide by zero. It's not something that we're allowed to do. It is not defined. We get undefined as our answer. So then this last one, 0 divided by 0, is also going to be undefined because, again, we're being asked to divide by 0. All right, the first number can be 0. If we look at 0 divided by 5, that's fine. It's the second number, the thing we're dividing by, that's not allowed to be 0.